Okay, problem 11. So now we are given that we have 2.33 times 10 to the 20th atoms of O. And what we want are the answer now in nanograms. So atoms has to go to moles, then we can go to grams, then we can go to nanograms. So 2.33 times 10 to the 20th atoms of O. First step is to cancel atoms of O. Man, I'm having trouble there. Okay, and we go to 1 mole of O, and that is 6.022 times 10 to the 23rd, Avogadro's number. That cancels those units. And then we have to cancel moles of O, and that's of O. And then I know from looking at that, but you can look up on a periodic table, that is 16.00 grams of O. Cancel those. And then we have to cancel grams of O and make that nanograms of O. And grams is the big one, and this is 1 times 10 to the 9th. There are a billion of the little ones, and that cancels grams of O, and we're at our answer. So let's do that arithmetic. And then my answer that I come out with here is, there we go, 6.19 times 10 to the 19, 6.19 times 10 to the 6 nanogram. Question 12, I could not get the answers on here as well. So this is just a measurement. Do we know how to use these devices to make measurements? And remember, what we do is we always go to the digit that we all agree on. In this case, we know it's more than 87, and this is 88 up here, so this is 0.1, 0.2, 0.3, 0.4, 0.5, 87, 0.1, 0.2, so we're all going to agree it's 0.2, and then it looks to me like it's even with that, so we estimate on this last one. That's where the uncertainty is, and that would be the answer I choose. Now, actually, someone might read that as 87.21 or 22 or something, but those aren't choices. And the point here is that we agree, all of us, on 87.2, and then we estimate that last one. Okay, this next one, number 13, is straight up, do you know how to count the number of significant digits? And as usual, the problem is 0. And these, so this is a 0. It's in between two non-zeros, so it always counts. Out here at the end, these are on the right of a decimal and to the right of a digit, so they both count, and this would be 5 would be our answer. Now in problem 14, it's just, do we know the rules of when we do arithmetic operations? And so what we're doing is taking 249.362, adding that to 41, parentheses around there, and then we're going to divide that whole thing by 63.498. Now remember, parentheses first, we have to simplify this, and our rules for addition and subtraction, we look at the place of the decimal. So that's why we stack these up, and this would be 41 there. We'd add those together, 2, 6, 3 point, that becomes a 1, carry that, that's a 9, that's a 2, but this is good only to the ones. So that's as far as we can go, and that becomes 290, but that's all 3 of those are significant figures. So there are 3 significant figures in that number, and then we do the division, and we take the one with the fewest number of significant digits. We're going to do that division. This has 3 significant digits, not 2. That just happened to be a 0 because it was in the ones place. This says it had to be done to the ones. That means it's a significant digit. It just happens to be 0. So if I write that, I'd want to write that like that. And then I do my division, and I come out with 3 as my answer, or for number of significant digits. So the only possibility here then is 4.57. I just have a minute for this one. Let me just pop this in. This is given centimeters. What do we want? We want meters, millimeters. So we have to go to the base unit.